Hello guys, so let's discuss about today's LeetCode daily question. It says nth Tribonacci number. So she has given the definition of a Tribonacci number, which is the combination of the previous three terms for n greater than 0, right? We need to return the value of t of n given the value of n, right? So has given the prerequisites of t0, t1 and t2, and the constraints are very less, which is less than 37, and the answer is guaranteed to fit within a 32-bit integer. So let's look at the approach for solving this particular problem. Okay, so let's quickly dive into the problem and how to solve this particular problem. So we are given with t0, t1, t2 and the equation to get the next numbers in the series. Okay, so assume that we have n is equals to 3, right? So t of 3 will be depending upon t1, t2 and t0, that is equals to 1 plus 1 plus 0, 2, right? Similarly, if I tend to write this particular series, then this would be 0, 1, 1, 2, and next would be, we'll be solving with this, right? Because this number came from these three numbers, this number will be coming from these three numbers, right? So the next number would be 4, and after that this number will be coming from here, so that would be 7, and this series continues. Okay, so this is a very straightforward question with some math approach, right? This doesn't belong to any kind of algorithmic approach, so it's a straight naive question which just deals with a mathematical formula, right? So we know that to calculate the next element we can use these given constraints and we need to calculate the next element. Okay, so there are two approaches. So the first approach would be store the values and compute, and the second approach would be just arrive at the particular value of n. Okay, so you could use any of these two approaches. So we'll just discuss about the first approach first, and then we'll just move on to a second approach, which is just a enhanced version of the first approach, right? So for the first approach we are dealing with how to solve it using the previous values stored, right? So that we also call as caching, or let's just say storing some values. So you need a container to store some values, and if you are familiar with something which stores values is a variable, right? And if you are visualizing that variable in multiple dimensions, then that will become arrays. So you will be storing your particular input in this arrays, right? So you will declare an array to store the computation value, right? So which is an of size n. No, you shouldn't be declaring with size n because you want to access the n. The n value is given as 3 or the n value is given as 4. You need to return the value of third element or the fourth element or t3 element or t4 element, if in that sense. So you should be storing n plus 1 because you want to access the nth index, right? So you will be storing it with n plus 1, and you need not worry of initializing this array. So if you are using C++, make sure you initialize this array with some random value, but if you are using Java, it is already defined with 0 when you are defining the array. And I straightforwardly know that n should be greater than or equal to 3. If it is less than 3, I'll return some value. Okay, let's handle that base condition somewhere else. So if n is greater than 3, mind you, if n is greater than 3, check if n is greater than 3, compute, right? Compute until n. else if it is less than 3, return value, right? Okay, so you understood this approach, right? So compute until n can be used using a iterative approach, and iterative approach, if I mean, we'll use loops. Okay, so I'm defining a for loop, right? So for I know that I should be greater than or equal to 3, so I will be starting from 3, and I will be less than or equal to n because we want to access till n I plus plus, right? And my array of I will be depending upon array of I minus 1, array of I minus 2, array of I minus 3, right? Why? Because the given equation is Tn plus 3 is Tn plus 2 plus Tn plus 1 plus Tn, right? So if I send this particular 3 over here, then that will become Tn plus 3 minus 3 is equals to Tn plus 2 minus 3 plus Tn plus 1 minus 3 plus Tn minus 3, right? So that will become Tn is equals to Tn minus 1 plus Tn minus 2 plus Tn minus 3, which I have written here. Each array of I will represent my Tn value, right? And prerequisitely we have T0, T1, T2. Can I assume these values to be stored in array of 0, array of 1 and array of 2, right? Makes sense? Yes. So my approach is this is the main logic, and this is the initialization before the main logic, right? Okay, so let's just quickly note down how to kindly write this particular code. I'll write the pseudo code. Okay, so I'll be declaring an array which makes of size, let's just say, I'll quickly write because n is already given in the function header. We'll have n plus 1, right? After declaring this, I'll declare my array of 0 is, it is already given in the question, which is 0. Array of 1 is 1 and array of 2 is also 1. So for int I is equals to 0, I less than or is equals to n, I plus plus. Now array of I minus 1, array of I minus 2 and array of I minus 3, right? We have converted that particular formula and you simply return your array of nth value, right? Okay, so this makes sense, Okay, I did a mistake here, which is I should be greater than or equal to 3, right? Yeah, I 3, you did it. But what if your n value is less than 3? If n value is less than 3, we already have these values, right? Can we just simply return that values? Yes. So what can I do is, if n is equals to 0, return 0. If n is equals to 1 or n equal to 2, return 1. Else you do this, right? Else you do this, or else it will throw an error if n is less than 3. Okay, so this code has a minor, complexity overhead where it is in this particular section. Why? Because you are using an auxiliary array which is consuming extra space of big O of n every time, right? And my judge, my online judge in the sense your LeetCode or HackerRank or CodeChef, which is uh, evaluating based on the compiler it is being designed, it will take the input up to 10 power 7, right? Or in the worst case 10 power 8 for some questions. But what if my n size is 10 power 9? It will throw a memory limit exceeded error, right? So this is where we optimize. Instead of storing in array, we'll just feed forward the stored values, right? We just feed forward the stored values. Okay, so this brings to a better approach. Okay, and this code that here you are looking at is a dynamic programming code, and we unknowingly just arrived at a dynamic programming code, right? This is how we write a dynamic programming code. Here are your base conditions. Here is your DP array on which the operations are done, and here is your DP array initialization and DP array computation and returning your answer, right? Okay, so this is a DP question, but in a very generic sense. It's not the application of pure dynamic programming, but yeah, let's optimize this questions approach in a very big manner, right? So I will make a very subtle change, but before that, let me just hop on to this series. Okay, we have a series this 0, 1, 1, 2, 4, 7, right? So let me just quickly write that thing here. 0, 1, 1, 2, 4, 7. Okay, so this is n is equals to 3, n is equals to 4, and n equal to 5, right? Okay, so before getting through these all stuff, let me just ask you one thing. Let me just ask you one thing, that to get this 2, we use these three things, right? We just use these three things. And to get this 4, we used these three things, right? And to get this 7, we used these three elements, right? And to get the next element, we'll use these three things, right? Okay, so what am I doing is I am defining a window, or just say a block, which occupies three elements, and I'm sliding it by one time for each number, right? Right. Okay, so there is this can be assumed as one of the sliding window approach, but not completely, because we are just not moving. I'll just show you, because sliding window uses a different kind of protocol, uh, and here the approach is quite simple. So previously we declared the array, right? So for I is equals to 3, I less than equal to n, I plus plus, we are doing this, right? And answers okay, and my answer is computed using previous terms, right? My answer is computed using the previous terms. Okay, cool. But after the previous terms, what happened, right? So for computation of 2, let me just write in a different color. So 0, 1, 1, T0, T1, T2, and T3 is 2. Okay, and next for T4, okay, so this, let's just say Tn, okay, and this is 2. We got these three things, 1, 1, and for to get 4 we use 2, right? And we got 4. So what we are doing here, so after computation of your answer, the answer is stored in T2, the T2's value is stored in T1, and T1's value is stored in T0, right? So instead of the array, can I just simply declare three variables, T0, T1, T2, right? And my answer will lie at what? Will lie at the T2, obviously, right? Because you are propagating the elements. Okay, so I'll quickly define my int T0, which is 0, T1 is 1, and T2 is also 1. Okay, so I'm taking an auxiliary variable which is inside the for loop, so it takes only one space, right? So it doesn't matter. T0 plus T1 plus T2. Okay, now your T0 will become your T1 because we are storing it, and your T1 will become your T2, and your T2 will become your answers, right? And after the end, suppose let's just say three iterations you have done. Now your answer is 3, but where does this answer lie? T0 contains 1, T1 contains how much? 1, and T2 contains 3. So your answer lies at 3, right? So now return, simply return T2. So here in this particular question, the array is taking big of n complexity and space complexity exactly, and the computation is big of n, right? But here we have 1, 2, 3 and 4 variables, and the space is big of 4, comma, space complexity and time complexity is big of n, so which is way lesser. So it is memory efficient, and this particular solution, I guess you will just if you glance through this particular solution, you might end up solving it in your language of choice. But even if you are still stuck, I'll provide the solutions for both in the next upcoming slides, in the both C++ and Java for both the approaches. And make sure you like, share and subscribe to the channel for daily LeetCode videos and the solutions. Thank you.